is the R load for diode full. Yeah, 3-phase rectifier.
Okay. Simulate it and show me the results.
So is this visible?
Yes,
Hello?
yes, it is visible. Yes.
Yes, sir.
This is
So
for diode rectifier.
yes, sir.
Non-control rectifier.
Uncontrolled with R load.
Okay, okay. So can you go for the same simulation for control rectifier?
Sure, sir. So is the circuit visible?
Yes, how much firing angle is there?
30 degree.
Okay, please simulate your results.
So is it visible?
Yes, it is visible. Acha, so your firing angle is 30 degree. Now increase the firing angle to 90 degree. Then let's see what happens.
So this is happening. This is the output voltage.
Voltage. Why it is
So,
like that? Hmm? Annie?
yes, sir.
Acha, make it your angle is 60 degree or 30 degree.
So this one was 90 degree. You asked me to change it, right?
No. Initially it was 30 degree or 60.
Yeah, initially it was 30.
Make it 60. Then let's see.
Yeah, this is the output voltage for that.
Annie?
Yes, sir. This is the output voltage for 60 degree.
60 degree. Acha, is there any changes? Can you please incorporate one digital multimeter across your load? Both the value are same or different? How much voltage, average voltage in your output?
Sir, I'll have to check.
Check it.
So these are the readings I'm getting for 60 degree for when I've connected these probes.
So how much voltage, output voltage? It is not visible from my end actually. Properly, I'm not able to see.
Okay.
Average voltage is how much?
Sir, I think like even it's not very visible to me properly right now. I think it's because I'm sharing. It's around 107 volt.
Average.
Yeah. This is for 60 degrees.
60 degree, 107.
Yeah, that's what I'm getting.
Acha, so make it So now you can make it for 30 degrees. So what is your average voltage?
So for 30, it's 149 volt.
And 60 it is 107.
Yes, sir.
Okay, so what happened in 90? So why it is not coming? It should come.
Sir, I'm not sure. I'm not sure why.
Simulation time, I think some problem is there. Make it auto. Let's see what happened. Go to grapher.
Sir, I'm not sure why that is. Yeah. Yes, sir. I'm at the grapher.
This is for 90 degree.
No, sir. This is for 60.
No, I am asking you for 90. Why it is not coming? Make it 90 and
Okay.
go to the grapher. Why the problem is encountered?
Yeah, this is.
Then make it auto.
Sir, how?
How? You don't know.
No, so this is
Right
what
click
I've
karo.
been doing reports.
Right click. The auto is there na? Auto zoom.
Yes, sir. Yeah, this is still what's coming.
The time is less. I think some problem is there. Why this is not coming?
Sir, I'll look into it and I'll get back to you.
Okay. So I shall go to that RL load.
The controlled or uncontrolled?
First uncontrolled, then controlled.
Okay, so this is the uncontrolled. Run it. Yeah, sir. I think there's some problem. It's running the diode R load one. I think I've run it too many times. Yes, sir. This is the RL one.
Now for control, this is uncontrolled. For control,
This is uncontrolled. This is for the controlled.
Now make it angle 90 degree.
Mhm.
What is your average output voltage?
This is my output voltage. Yes, sir.
So what is your average output voltage?
I have to change. For 90 degree average output voltage, I'm getting 8.78 volts.
Nearer to the 8 point something. Na? So make it 120 degree. Now angle make it 120 degree.
So 8.17.
Okay. This is for RL load. Now go to that RLE load.
Yes, sir.
Waveform, please show me the waveform. Wave from?
For 120 degrees, sir.
Some spikes are there. I maybe. Okay, now open the RLE load.
Sir, shall I get the waveform?
Controlled. This is uncontrolled. Go to the controlled. Yes.
Yes, sir.
Okay, now make it make it 90 degree firing angle.
But
Make it 150. Okay, only single spikes are there. What is your average voltage?
for 150 degree? 47 volt.
Okay, so why it is coming to nearer 40? And a spike means you can say like that these are almost off. Okay, so no voltage, almost no voltage. Some spikes are there. Okay, why it is coming to range of 40? What is the justifications behind the results?
So I'm not sure.
Not sure. Why? It's a very simple thing. Just think about it and tell me. Very simple thing. You can give me the answer from your common sense. Nothing complicated thing. Very simple thing. Realize the problem. So increasing of firing angles means what? You are increasing the firing angle. Means what happened actually? Tell me. Turn on condition of the switch is increasing or turn off timing of the switch is increasing. Which one is
We're
increasing?
increasing the turn on time.
I'm not getting what happened. If you increase the firing angle, okay, so turn on period of the switch is increasing or turn off period of the switch is increasing.
Turn off is increasing. Turn on is decreasing actually.
Yes, for uncontrolled, how much firing angle? 0. Am I right?
Yes.
For uncontrolled
Yes.
rectifier, that is 0 degree firing angle. So you are getting the response throughout the cycle. Am I right? For half wave, only one cycle you are getting. For full wave, throughout the cycle, you are getting the waveform. Now you are making the devices controlled. Okay, then what happened? 0 degree means control and uncontrolled both are showing the same results. Okay, now you are increasing the firing angle 0 to 10 degree. So what happens? 0 to 10 degree means when the firing angle is 0 degree, that means switch is turned on at 0 degree. Are you getting my point?
Yes, sir.
Yes. So total time period is, if you consider the total duration of the span is 180 degrees, so 180 degrees is 20 milliseconds. So 0 degree means just initial condition, it is a standard. Okay, now we are making that angle is 10 degree. 10 degree means what happened? Turning on position means when the switch will be turned on, that is 10 degree. Okay, 10 degree delay of your uncontrolled switch. Means for uncontrolled what happened? It is 0 degree turned on. For control 10 degree means first 10 degree it is not there. Means turn off period is 10 degree. Okay, so after 10 degree it will be turned on. Now we are increasing the time. Okay, so 10 degree, then 20 degree, that you are first you are considering 30, then 60 means after 30 degree it is turned on. 60 means after 60 degree it is turned on. 120 degree means after 120 degree it is turned on. Means that on time durations. Okay, on time duration is coming later. Okay, so off time duration is more. So up to that portions, 40 degree means now there are several conditions that your firing angle it should arise beyond of your back EMF. If it is less than back EMF, so it will not turn on. After only it can turn on after when that back EMF is less than of your time period. If you consider the sinusoidal, okay, when that sinusoidal waveform is just crossing of your back EMF, only that instant your switch may be turned on. If it is uncontrolled rectifier, okay, if it is controlled rectifier, then it will be waiting for the firing pulse. Annie, are you getting my point?
Yes, sir. So here
Okay.
it's coming
So
this because
yes,
the on time
so yes, gradually you are increasing the time period. Okay, now we are talking. So average voltage, how much? When it is not turned on, your back EMF will come your average voltage, output average voltage. Okay, are you getting my point? Now you are turned on. Now your solid state device is turned on at 0 degree means for this case that is theta. When your sinusoidal waveform is just crossing your steady state back EMF. Okay, it's just crossing. After that, it can turn on. For uncontrolled, directly it is turned on. For control, it is waiting for firing pulse. Suppose some alpha degrees of firing angle. After that, it is turned on. In this study, what we are doing in these simulations, we are varying the firing angle. You are getting my point? Suppose our firing angle is too big. Okay. So again, that when the sinusoidal waveform is touching, crossing its peak, again goes down and just below of your back EMF. Again, firing pulse is there, but it is not turned on. Okay, so that's why for 120 degree, beyond 90 degree, 120 degree, 150 degree, what happened? Maybe firing pulse is given, but switch may be turned on. But the problem is that it is less than of your back EMF. That's why you are not getting any output. So whatever output you are getting, only the average output voltage you are getting, that is only your back EMF. You are getting my point?
yes, sir. Understood.
Why it is nearer to the 40? 40 is your back EMF that you have given here.
Okay.
Is it understandable now?
Yes, sir. Yes, sir. Thank you.
Very simple thing, just realize it. Whatever we are studying here, you just realize it. Okay, otherwise what happened? There is no meaning to do that simulations. Okay, so basic philosophy we have to understand. Okay.
Yes, sir.
Okay. Did you prepare the report?
Sir, I've prepared everything except for the observation table.
The main thing is pending. Okay. So for this study, main important thing is your observation table. Okay, complete that observation table and plot the curves. Okay, from
Yes,
your
sir.
Excel. Okay, Excel, you're just plotting all those curves. Okay, so we can understand efficiency. Okay, in terms of efficiency, output voltage and current. Okay, so please plot it. Okay.
Yes, sir.
From your observation table. Okay, thank you. Next one is that roll number 324.
Yes, sir.
You please share your simulation.
Just a second. Is it visible, sir?
Yes, it is visible.
Yes, sir. So this is the one for the diode, three-phase diode one, uncontrolled one.
What is the batch number of your diode?
Sir, this is the MUR, this one.
MUR?
MUR R40, MUR R60G.
MUR 60? No, 460.
460, sir. 460G.
Achha, what is the specifications of this MUR 460 diode? Why you are using MUR 460 in this study? Why not MUR 160?
Sir,
Don't know.
no, sir.
Why? So from where you are getting the diode?
Sir,
From
as
the
per the,
as
sorry,
per the
sir?
as per the manual.
Yes, sir.
Okay. Achha, please explain what you are doing. Explain me.
Yes, so this is the one for the diode one for our road, and next one, uh, this one. This is for the thyristor one. Here is the graph. Then next is the for RL load.
Achha, you can vary the firing angle up to 150.
Yes, sir, just a minute. So this is the graph for the 150 degree firing angle.
150.
Yes, sir.
Can you please explain it? Your graph. What happened here? What is your average voltage?
So just a second. So do I need to tell the value?
Hmm?
So do I need to tell the value?
No, what is your average voltage? Average output voltage.
So it's coming at 63.2.
63 voltage average.
So microvolt.
Hmm?
63.2 microvolt. Near to 64.2. It's keep on changing the value. So it's nearly showing this value.
No. Go to your grapher. Show me the results. So that it is showing 63. So is it correct or wrong? Is it correct?
It's yes, sir. Just a second. Run. It's so this is the graph.
So
Yes, sir.
what is your output voltage? This one. So it is showing 63 volt.
The output is 0.
But it was showing 63. How is it possible?
So it's microvolt, so it's nearly equals to 0.
No,
Maybe
you
not
zoom
sure.
that one. You zoom karo. You zoom it.
So this one zoomed in.
Hmm.
So I zoomed it.
So how much voltage is coming here?
So 0.
0. But your average, you are telling that it is 67. So how
So
both are
that's
relevant? Huh? How are they relevant?
so the proof value, the proof value is coming as 63 point something.
Pro value.
Probe values are the one I shown your voltage probe on.
The voltage probe value.
It's the value of the voltage, yes, sir.
Why it is coming?
So it's nearly to something micro, so maybe it converges to 0 volt.
But if micro means, then that voltage may become in micro range. But why 67?
Also, it is there in the microvolts, so
Microvolts. So it should be the microvolt.
yes.
Why 67 you were talking about? Difficult question or simple question?
It's a simple question, but
That what?
also due to the ripple factor.
Ripple factor, baap re baap. So means
I know it's not ripple one, but the probe scaling value may be the
question, whatever question I am asking now, just for your, just previously I discussed with Anand.
micro value will be near to the zero now.
It should be take 0. So why 67? So this is very simple and common question. Very simple question, nothing complicated one. Just for your common sense, you should respond it.
I guess so. The probe value was showing 63 microvolt, so that's why I said it nearly to zero.
It was microvolt. Probe value how much? Show me.
Just a second.
You are telling us only 67 volt. You are telling, or
Yes, it was nearly 64, 63.7 or 64.
Voltage or micro voltage?
Microvolt, sir. Here is the
Microvolt.
Yes, sir.
No, top one, what is written? Top upper one. Oh, microvolt. That means 0.
Yes, sir. Problem.
That means 0 almost. Okay.
Yes, so that's why I'm saying it is in microvolt, sir.
Okay. Okay. Then show me that other simulations.
Yes, sir. So this is for diode RL1, RL load. And the next one is for the thyristor RL load. Then this is for diode RLE load. And this is for thyristor RLE load. Yes. So for the report one, I haven't yet completed it fully. I mean, I've pasted all the graphs and the circuit diagram, but haven't done the observation table.
Main portion is pending. Observation.
Yes.
Okay, complete karo observation table. Okay.
Yes, sir.
And next roll number 325. 325 absent. Roll number 325 absent. Those are not giving after giving attendance, they ran away from that meeting, so their attendance will not be considered and proportional marks will be deducted from your evaluation. Okay. Roll number 326. 326. Roll number 341. Roll number 341.
Yes, sir.
Vidyasagar.
Yes.
Show me your simulation.
Sir, I have not done actually. Sir, my health was not good, sir.
Health was not good. What happened with your health?
सर पूरा बैक स्प्रेन हुआ है, ऐसे में गर्दन नहीं ये कर सकता एक्चुअली। मैं क्या था तो डॉक्टर थोड़ा बेड रेस्ट के लिए ये किए हैं 1 हफ्ते। आज मैंने 1 हफ्ते से हुआ है सर।
तो तुम 1 हफ्ते से बेड रेस्ट में हो?
ये नहीं,
विकास?
आज मैंने अभी थोड़ा ठीक हूँ। मैंने अभी एक
Acha,
आज
I'm not okay. You are okay. Please take care. Okay, and get well soon. I'm just taking I'm just a little conversation with you. Okay. So suppose, okay, you just consider, suppose it is 2022. Okay. Now you just go to around 2023. Okay. This time, same day, same situations. Okay. Now you are working for a company. Okay. So what happened, and there is some big assignments. So what happened in company? So means when we are working somewhere, so they're giving some projects. Okay, all the time we are fighting for the projects. Okay, so if any project, new project has came, means that employee are very happy to solve that project. So based on their projects, and they can some money or some fund has came to the company, and from that fund they give the salary to their employee. Okay, that is a very common thing. In our institute also same thing also going to be happen. Okay, gradually the total thing is going to be happen. Okay, that is different issue. I'm just taking one example. And you are having that problem, medical issue. Okay, then what happened? As per my knowledge, okay, I have some actually I have some friends. Those are working in different companies. Okay, so they are telling me they are having tremendous work pressure, and especially for the virtual mode. Okay, so day night they are working. Even they are having some problem. Basically, working from that virtual mode means the back pain as well as that headache. It's a very common. Okay, so they are working. Okay, so how they are working? Okay, so okay, doctor suggest you to take for the rest. Okay, very good, but that lab is conducted after 1 week. In between there is a mid sem. Okay, you are finally a student. I think some course load is less. So if you have the intention, you can. I think you can solve it. Okay, but okay, take care about your health. But I'm not. I hope that you are a good student, because that means I know you. I told you na that as a faculty advisor, individually I know you, all of you. Okay, so who are having the potential, I know that I can remember that in my measurement class. So when we are solving the gate problem, so gate question answer. So you are repeatedly you are giving the response that time, and right now I am not getting such type of response from your end. Okay, that's why I am quite disheartened. Nothing else.
sir,
Okay, and end of the day I am good wisher all of you. Nothing else. So
sir, last time also I have shown you, but this time, sir, genuinely I'm having problem, and doctor has given me muscle relaxer, Myofree. So I'm taking it and I'm feeling better, sir. From last this
okay,
actually
okay, no problem. Next class you please show me. Okay, Vikash.
I was playing badminton and suddenly that sprain came and so
Okay.
okay.
Next one is 337. 337. Aman Kumar Sharma. Absent. Okay. Roll number 810. Roll number 810. 810 Sonam Zangbo. Roll number 809. 809.
Hello, sir.
Prema.
Yes, sir.
Share me your simulation.
Sir, I have joined through mobile phone, sir. My laptop was crashed, so I just sent to the repair yesterday, sir.
Roll number 807.
Yes, sir.
Tashi.
Yes, sir.
Show me your simulation.
All right, sir. Sir, is my screen visible?
No. Yes.
Sir, this one is for uncontrolled. So, and this is for controlled. This is for R load, this is for RL, this is for RLE.
One by one, show me the simulation.
All right, sir. Sir, this is for R load, uncontrolled. This is the
Simulate
graph
karo.
waveforms. Yes, I simulated.
Close it. First close it. Simulate. Simulate karo. Okay. This is for uncontrolled.
Yes, sir, for R load.
From the results, how do you know that is an uncontrolled?
From the result, sir.
From the result, how do you know it's an uncontrolled?
Sir, the output voltage follows the input voltage waveform.
Question is that how do you know that's an uncontrolled? Why not it's in control?
Sir, and sir, in uncontrolled, there is like no firing angle and all. Like,
No.
firing angle, like we don't give firing angle in uncontrolled.
Okay. So that's why you can understand that's an uncontrolled.
Yes, sir.
What is the average output voltage?
And it does not get off, sir, after becoming on.
What happened? I'm not getting. What happened?
It does not get off, sir, like after becoming on. Like.
Okay. Show me the other simulations.
It's for already uncontrolled. So this is for RLE. Uncontrolled.
RLE for uncontrolled. Okay.
Yes, sir.
RLE, how much? Okay. One thing.
Yes, sir.
Okay. Go to that controlled one. Now show me the control response.
Which ones are early? Shall I simulate, sir? Hello?
Show me the simulation for control.
This is it, sir. Hello, sir? This for RLE.
This for RLE.
Yes, sir.
Okay, so how much firing angle is there?
Firing angle, I've given 60, sir.
$60.
Yes, sir.
And now make it. Now make the back EMF 150. Now make the back EMF 150.
150. 150. Just coming something like this. Sir? It's coming like this.
So what is your output voltage? That's my question.
It's coming like this.
What is your output voltage?
Sir, output voltage is this one. This one was our output voltage.
Why it is coming like that?
Output voltage, no, sir?
Why is it coming like that?
Sir, because the thyristor
Zoom
is
karo.
not getting.
Zoom karo. You make
Zoom.
It's zoom.
All right.
From 100. So from 100 volt in y-axis, make it zoom in y-axis.
Y-axis, no, sir. So is it okay, sir?
No, not okay. Most of the portion has cutting down. Na? I want to see that average voltage.
Okay, sir.
Only that straight line. That I want to see. Make it zoom. Straight line. You make the zoom only the straight line. Okay.
Sir, I'm doing, sir.
You're doing okay.
So is it enough?
Hmm?
Yeah, is this enough? Hello.
Okay. So what is your average voltage?
Sir, can you give me a minute? The guys.
What is your average voltage?
Sir, can you give me a minute? Like this sound from background is
Okay,
too loud.
you have the multimeter, na? You click
just-
here. The multimeter you are connected, I think so. Across your.
Yeah, sir.
Minimize it. Why you close it? Minimize karo.
Okay, sir. Okay.
The multimeter, click the multimeter. How much?
It's 150, sir. 150 volt.
So your back EMF is 150 again. Average voltage is 150. Why?
Because thyristor is not getting on, sir. That's why. So
Why
output
thyristor
voltage will be
not
equals to
on?
back EMF.
I'm not getting what happened. Please repeat the answer.
Since thyristor is not getting on, so like the output voltage
Why
will
it is
be
not getting on?
equals to back EMF.
Why the thyristor is not getting on? I'm asking the question means that's on the vibe. I
Yes,
have
sir.
also noticed that. Hello. Am I audible?
Hello.
You
Sir,
are properly audible. Am I audible?
I'm cracking, sir.
I'm telling you, you are properly audible. Okay. So I think I'm also audible from your end. That I'm telling you whatever question I'm asking all of you, I'm just noting down, just for like that vibe. Okay. So can you please tell me why average output voltage is 150 and your back EMF also 150? Why both the same? Both the same. No need to do the simulation. You just tell me the answer. If simulation is right, but I want the justification.
Sir, I'm not sure about this.
You are telling something, no? Thyristor is not turned on. So to speak on your answer. If you have the confidence, why you are just changing your answer? Whatever you are telling, that may be correct, but you should give me the proper justification. That I am asking. I am not telling that you are wrong. I am asking for the justifications. You are telling thyristor are not turned on, not conducted. So that's why it is 150. My question is that why it is not conducting. I am not telling you are giving me the wrong answer. You are correct. Thyristor is not conducting.
Yes, sir.
My question is why? What is the justification? That is back EMF. What happened in 60 degree? Okay, when your back EMF is nominal value, means 40 volt. Okay. So at 60 degrees, whatever your average, when back EMF is 0. Okay. When the back EMF is 0. Okay. So now 60 degrees there. Okay. 60 degree you are constant. Now back EMF is 0. Okay. Are you getting my point? Hello? Am I
Sir,
audible?
your voice is cracking, sir.
My
In the
voice
middle.
is cracking, but your voice is your voice is properly audible from my end. I think some network issue is there in from your end. I think so. Is
don't
my
know, sir.
voice is properly audible from your end?
From my end, sir.
Not your end, other students' end.
Oh.
Am I audible properly?
Sir, your voice was cracking a lot.
Yes, sir.
Cracking a lot.
Yes, sir.
Sir, your voice is breaking, sir.
Okay. Cracking a lot. Okay. Just for a moment. Am I audible properly now?
Yes, sir.
Better.
Yeah, yes, sir. Yes, sir. Better for now.
Okay. I am disconnecting my intercom from that network. So due to intercom, some maybe interference are coming. That's why I am not properly audible. Okay. So that I am talking about it. So suppose your back EMF is 0. Okay. So then what happens if you increasing your back EMF? So after some time, it may be you can check whatever your output. So it is 100 volt peak. Okay. So this is beyond that value. Okay. If you make the maximum one, whatever RMS or maximum, if that vacuum is beyond that value, so how it will conduct? It will not able to conduct. That's the main reason. Okay.
Yes, sir.
Okay. So did you prepare that? Did you prepare your report?
Yes, sir. Like not all, but I've done the initial parts.
No. Did you prepare the observation table?
No, sir. Just the initial
Main
parts.
thing you have not prepared. So no meaning of it.
Theory and all.
Okay.
Just something.
Okay, so first complete the observation table. That is most important. Complete the observation table with variations of your load parameters, variations of your firing angle. Okay, and then plot the values that are more important. Okay,
So here, which one do you have to vary?
I'm not getting what happened.
So in this simulation, which one do you have to vary for observation table?
Hmm?
Hello?
I'm not getting what you are asking.
Sir, I was asking like which one do you have to vary for observation table in this
Yeah,
simulation?
observation table for all the simulation to provide the
Yes, sir.
observation table. Okay.
But okay, sir. Okay, fine. Thank you, sir.
Okay, so those are not unable to attend the class due to health issue. Okay, so their attendance is not considered. Okay, so you can apply for that medical leave. So academic section will approve your attendance. Okay, so it's happened. Okay, if I am not feeling well, so I am not able to attend my class. So what happened? For that one, I have to take the medical leave. Okay, so it's not like that it is doing on virtual mode means I am just standing on and giving my attendance and I am present in the class. It's not like that. Okay, so it's happened. Some of the students may happen the health issue, so their attendance is not been considered. Okay, those having health issue, you may apply for the leave from the academic section. If they will have approved, so your attendance also been approved. No problem with that, like previously. Okay, so those are having health issue. No need to tell me. So and your attendance is not been considered. Okay. I have shared one file. All of you getting that one? I have shared a file. Do you receive it? Please let me know.
Yes, sir. Yes.
Yes, sir, we can see.
Okay, so so we are doing the study on full wave. Okay, sorry, half wave, full wave, then uncontrolled, then full control, then semi-control. Okay, so for single phase and three phase. So for three phase, one thing is still pending, that is semi-control. Okay, means semi-converter. Okay. So again, we will see the same type of study for different load, R load, RL load, and RLE load. Okay, for the semi-converter. Okay, so you know that basic process. How do we prepare the write-up? So first, some basic theory will be there with the proper circuit diagram and the waveforms. After that, the mathematical expressions to calculate that your average output voltage, average current. Okay, basically when we are preparing the observation table, so all the parameters are very much needed. Okay, so we know the input voltage, input current, input power. Okay, so as well as we have to calculate the output voltage and output current. Okay, so and we can also measure the actual output voltage and actual output current from the multimeter and respective waveforms. Okay, for voltage and current. Then what we are calculating, output power we are calculating. Then we can find out the efficiency and the error. Okay, what kind of error? Voltage error. Okay, so calculated output voltage and measure output voltage from the multimeter. So we can find out the error. Okay, more or less that error is very nominal, not more than 1%. Okay, so very nominal. Okay, 1-2% error maximum. Okay, but what we can see, we can find out that error. So from that one, we can understand that our study is okay. We can cross check that our study is good and our study is correct. Okay, and the efficiency. So from the point of view efficiency, I'm telling you one thing. Okay, so we have already covered different simulations for single phase and three phase. So after completions of this semi-converter, I am advise all of you. Okay, so prepare one document. Okay, not a document, that document contain one table. Okay, 1-page document. Okay, that contains a table. Okay, tables of what? For same parameters. Okay, suppose varying of firing angle. Okay, varying of the firing angle, same parameters, same load parameters actually. Okay, so we need to see that how much efficiency, okay, is coming in our single phase half wave. Okay, for controlled and uncontrolled. Okay, for uncontrolled there is no firing angle, maybe considered as 0. Okay, so for uncontrolled, how do you define? So firing angle making 0. Okay, so firing angle, if you are making 0, then all the results are coming for single phase, three phase for different patterns. So that will be uncontrolled. Okay, so now you are giving some firing angle. Okay, so maybe 30 degree. So you'll get some results. Okay, that should be the controlled one. Okay, so for single phase half wave, single phase full wave. Okay, for R load, so table will be prepared for 3 different loads. Okay, R load, RL load, and RLE load. Okay, for R load, for RLE load and RL load, you can also prepare one table for freewheeling diode associated table. But if you are not having the data, okay, so you cannot do that one. Okay, so preference is that R load, RLE load, RL load, and RLE load with varying the firing angle. Okay, so you need not do the same simulation again. Okay, that you have the data. Okay, you have the data. You just prepare a table and plot the data. Okay, for uncontrolled. Okay, for uncontrolled half wave, what is the efficiency? Okay, for uncontrolled full wave, what is the efficiency? Okay, for uncontrolled three phase, I am talking about single phase first, then three phase, what will be the efficiency? Okay, for now we are varying the firing angle. So we have to see the efficiency plot and the output voltage. Okay, efficiency, output voltage, that graph we are plotting, that curve we are plotting, efficiency, output voltage, output current. Okay, so output current is actual output current and actual output voltage from your multimeter. Okay. So from this table, we can see that which converter will get more efficiency at which firing angle. Okay. As well as which converter provides us most highest average voltage. Okay, basically inputs parameter are same almost. Okay, more average voltage, more output current. So from that table we can understand. So if we are able to prepare this table, so crystal clear idea we can get from this study. Okay, so if anybody asks me to design a converter for this type of load, so which converter is suitable for our study, for our design aspects? Okay, that whatever we are studying here, okay, so the view should be different. Okay, that should be in design aspect, as we are the technologist. Okay, we are getting bachelor in technology. Okay, there is a difference between engineering and technology. Okay, so when you were in first year, that day, that basic electrical engineering class, I discussed the difference between the technology and engineering. Okay, so now I'm not going to repeat it again. So technology means all should be in applied mode, means application purpose. Okay, so we have to think about very smart manner. Okay, so what is our application? So the table you can prepare it, that can make maximum 5 to 10 minutes job. Okay, so see the table. Okay, so next class, that is not any experiment. Okay, not under any experiment, just for the study. Whatever we are study, we just make a spreadsheet. Okay, that can be, you can done in Excel file also, no problem with that one. Okay, so next class you can show me. So from that Excel file, we can conclude that which converter gives us the better performance. Okay, in terms of efficiency. Okay, so in terms of output voltage and current. All of you getting my point? And this is our basic study about semi converter, our three-phase semi converter. Same kind of study we'll do for R load, RL load, and RLE load with the variations of the firing angle. Sometimes we are also varying the parameters. Okay, but no need to write that low inductance value. Okay, high inductance value. Okay, we can write it, but we have to specify it. That is our rated inductance value. So if we pointing some percent that it is low inductor value, so which respect I am telling it that is a low inductor value. Okay, so we have to know the rated value. As we don't have the rated value with us, okay, as we are varying the parameter, okay, so optimum one we have to calculate. Okay, so we can say like that for variations of the inductor value for different values. I know that in manual, whatever I have provided, it was mentioned and low inductor value. So that is wrong. Okay, that we can change it. Okay, that's why that corrections I'm telling now. Okay, so the basic simulations you have. Okay, only now you are just mixing up both the switches. Okay, uncontrolled and control. Oh, sorry, controlled and uncontrolled. Okay, and you will get that value. Okay, so different types of load you are having and the parameters. So tables are sorry, that screenshot of that parameter value also given. So from where you can easily understand which value you need to give and how to fetch the data. Okay, and what kinds of waveforms are coming. Okay, cross check it. Is it coming? Whatever it's coming, is it right or wrong? Okay, so how do you understand that is right or wrong? Simple thing. That's why I'm telling you, calculate the output voltage. Okay, calculated output voltage and the measured output voltage. Okay, both are is more or less same. Okay, and error is 1%, 2%, up to 2%. 2% is also more. So you can say like that, below 5% actually. You can say like that. Okay, that is right. Okay, so this thing is very important. That's why I'm telling repeatedly. I'm telling. Okay, so the table is that screenshot is given to understand the block parameters. Okay, what you need to fix up it. Okay, and different firing angle, you can pick the value with the different parameter value. Okay, I have already shared this document for your reference and you can simulate it. You can edit your previous files for the simulation, but all the file keep it fixed. Okay, keep it with you. No need to delete and other things. So I'll ask for the simulation file also. Okay, at the time of submissions. Okay, make a zip file and collect the simulation file also. Okay, so keep it with you for your further application. So some basic observation table is given, but it is not totally complete. Okay, the complete one I have told you. Okay, so that as per that idea, you will just prepare it. Okay, so I hope you are getting my idea. Okay, any doubts from your end? Hello, any doubts from your end?
No, sir.
Okay, so no doubt means I have already shared that file, so you will get it, I think so. Okay, so okay, here I am just concluding today's session. Okay, after that the exam will be that question will be shared with you for the MCQ. Then Viva will be there, small Viva will be there. Okay, so then after completions of that exam, so you just leave them. You can leave the meeting. Okay. So the call will be coming to your mobile from MS Team for that Viva Vasi. Okay, thank you. And Shuchishmita and Vikash.
Sir.
Both of you please share the link and the important instruction, write it in the chat box. Okay.
Okay, sir.